Okay, are you ready for more? Yay. So, our directions say one solution to the equation A plus B plus C equals 10 is that A equals 2, B equals 5, and C equals 3. So if we substitute these numbers in for A, B, and C, we would get 2 plus 5 plus 3 equals 10. 2 plus 5 is 7, plus 3 equals 10. Yes, true. The question is, how many different whole number solutions are there to the equation A plus B plus C equals 10? Explain or show your reasoning. So first of all, we need to understand that whole number means the non-fractional, non-decimal numbers, 0 and up. So whole numbers would be 0, 1, 2, 3, and so forth. So we're looking for combinations, A, B, and C, that we can add together and equal 10, and they have to be, they can't be negative, they can't be decimal, they can't be fractional, and they do include 0. So this is a problem that actually is a branch of mathematics called combinations and permutations. And you might get into this when you get up into like Algebra 2. Combinations and permutations. And both of these, oh, I messed that up, permutations. Both of these are branches of mathematics that explore the number of different ways things can be put in order. And the difference between them is combinations, you don't care what order they're in. Permutations, the order matters. So for example, if you said, I want to have certain toppings on my pizza. I want pepperoni, mushrooms, olives, and I want to know how many different combinations of pizza toppings you could have at a pizza parlor. And it wouldn't matter what order those toppings were listed. For example, a permutation, if you have a combination lock that has 30 different numbers on it, and you said how many combinations of numbers, how many different combinations could you make on that lock, the order would matter. So for example, the combination 1, 7, 18 would be completely different than the combination for a lock that was 7, 1, 18. Even though these are the same three numbers, they are two different combinations. So in permutations, the order that objects are in make a difference. In combinations, it doesn't. If you said a pizza with sausage, onions, and peppers, it's going to be the same as the combination of peppers, sausage, and onions. Okay, so in combinations, this would count as the same combination of this. In permutations, this would not be the same as this. So anyhow, what we're looking at in this problem are really permutations because A, B, and C are considered to be different parts. They're like the combination lot. So first, let's establish that since it has to be whole numbers, and we're trying to come up with three whole numbers that have a sum of 10, none of the numbers can be larger than 10. So the only numbers A, B, and C can be are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those are our only possible values for A, B, and C. So let's do this systematically. Let's start out with the possibility for A. If A is 0, and I need a sum of 10, let's say B is 0, then C would have to be 10 because everything has to add up to 10. second possibility is A is 0, B is 1. So C in this case would have to be 9. If A is 0, B is 2, C is going to have to be 8. Remember, I always have to keep these adding to 10. So we can just kind of continue. This way we're not missing any possible combinations. And you can see a pattern. It makes this a little bit easier. So as B is increasing by 1 each time, C is decreasing by 1 each time. Let's get all the way through A equals 0, all the possibilities where A could equal 0. And that's it. So when A equals 0, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possibilities for the remaining combinations of B and C. 11 possibilities. So now let's go to where A equals 1. So if A equals 1, B equals 0, then C has to equal 9. If A equals 1 and B equals 1, C has to equal 8. If A equals 1 and B equals 2, then C has to equal 7. And again, I can see the pattern here. A remains the same each time, B is increasing by 1 each time, and C is decreasing by 1 each time. And always check, we're keeping our rows equal to 10. So let's finish this out. 3, I'm sorry, that's 5, this is 4, 6, 3, 1, 7, 2, 1, 8, 1, 1, 9, 0. And I can't go any further. I can't make this 1 and this 10. So those are all the possible combinations when A equals 1. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 combinations. So are we starting to see a pattern here? Looks like it. Let's do one more to be sure. Let's look at if A equals 2, B equals 0, C has to equal 8. If A equals 2, B equals 1, C has to equal 7. If A equals 2, B equals 2, C has to equal 4. And again, we're seeing this pattern, 2, 3, 5, 2, 4, 4, 2, 5, 3, 2, 6, 2, 2, 7, 1, 2, 8, 0. And that's as far as we can go because we can't go down any lower than 0 there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 solutions for when A equals 2. So we're definitely seeing our pattern here. So when A equals 2, there's 11. When A equals 1, there's 10. So we could say when A equals 3, there's going to be 8 solutions. When A equals 4, there's going to be 7 solutions. When A equals 5, 6 solutions. When A equals 6, there's 5 solutions. When A equals 7, there's 4 solutions. When A equals 8, there's 3 solutions. When A equals 9, my A's are looking like 9, sorry. There's 2 solutions, and when A equals 10, there can be only 1 solution. If A equals 10, B and C both have to equal 0. So we can just add up these solutions. 11 plus 10, plus 9, plus 8, plus 7, plus 6, plus 5, plus 4, plus 3, plus 2, plus 1. 11, let's see, 1 and 9 is 10. 18, 25, 31, 36, 40, 43, 45, 46. Carry the 4, 4 and 1 and 1 is 6. So there are 66 possible solutions. Yeah, it's probably a little more than you bargained for.